Okay, we're going to use logarithms, to solve equations when the unknown is a power, not in a power, is a power. I don't want to put you off, but we've got one more little rule to think about. So we'll go for that first. So suppose that log x equals log y. So I've kept the bases the same, and if I let log x equal log y equal p, then I can rewrite both of those as powers. So a to the power of p equals x. So that's just rewriting the logarithm as a power. And a to the power p is equal to y. And if x equals a to the p and y equals a to the p, then x must equal y. We're assuming that x and y are bigger than 0 so that we can take logs of them here. So, final rule, I think, until I come up with another one. X equals y if and only if log to the base a of x equals log to the base a y. This isn't always true of functions. So, for instance, if you have a squared equals b squared, you couldn't say that a is equal to b, because a could be minus 2, for instance, and b could be 2. So this only happens when you have a one-to-one mapping, but we'll talk about that a bit more next year. Just be careful with your solving of equations. So if you have, say, log 2 plus log 3 equals log x, the thing that you really mustn't do is just kind of go, actually I don't really like logs, so I'm just going to cross them all off and divide through by log, because log doesn't work like that. It's a function and it combines differently to normal numbers. So you need to combine logarithms first. So log 2 plus log 3 is log 6. But what this rule on the other side means is that once you're in this situation, so you've got log of left-hand side equals log of right-hand side, then I can deduce from there that x is equal to 6. You could, in theory, I wouldn't do it this way, but you could, in theory, approach this like so. So I could take away my log x, set it equal to 0, combine my logs together, hopefully you can see that, sorry, screen's not so bright. That's the same as log of 6 over x. And then if you undo that logarithm as might as a power, it's a base 10 log. So 6 over x is equal to 10 to the power 0. 10 to the power 0 is 1. And so x equals 6. I wouldn't go that way through. I just wanted to demonstrate that you can approach these things in different ways. But once you get log of something equals log of something else, then these two things must be equal to each other. Right, I'll do the next bit on the next video, I think. Sorry, that went on a bit longer than I thought it would.